In this lesson, we will learn about parallel lines and the angles they make with lines crossing them. Much of this lesson can be summarized using the diagram that you see. Notice that we have two lines, L1 and L2. They're parallel. And to represent parallel lines, we often use arrows. So these two arrows indicate that L1 and L2 are parallel. This line, which we'll call the transversal, cuts through these two parallel lines, and this forms 8 angles: A, B, C, D, E, F, G, and H. How each of these angles are related is explained below. Let's start with the first relationship, opposite angles. Opposite angles are angles that are across from each other and they're equal. Take for example angle A. Angle A is represented by this angle symbol and the capital letter A. Across from A is D, so whatever the angle for A is, D is equal to the same thing. So if angle A were 110 degrees, angle D would also be 110 degrees. Another example here is G and F. We can say that angle G is equal to angle F. The next relationship we're discussing are supplementary angles. Supplementary angles suggest that if you have a straight line, such as the one that you see on your screen, and this straight line is intersected by another, such as the one in blue, the smaller angle formed plus the bigger angle must add up to 180 degrees. So if this angle were, let's say, 50 degrees, this angle has to be 130. Therefore, 130 plus 50 degrees is equal to 180 degrees. In other words, both angles supplement each other to 180 degrees. Let's take a look at our diagram. C plus A would equal to 180 degrees. Let's write that down. Angle A plus angle C is equal to 180 degrees. Similarly, angle A plus angle B is also equal to 180 degrees. Let's do a bit of math here. Let's say that angle A is 110 degrees. And we don't know what angle B is. So we'll write down plus angle B, which we don't know. Both of these combined is going to equal to 180 because of supplementary angles. Now we can find angle B with a little bit of algebra. All we have to do is take this 110 degrees and move it over to the other side of the equation. This leaves us with angle B is equal to 180 degrees. And since this was positive and we moved it over to the other side, it becomes negative. 180 minus 110 is 70 degrees. Let's move on to the next rule. This rule is referred to as corresponding angles. And whenever you have two parallel lines, which we've denoted with the letter T, the angles in matching corners are equal. In other words, this angle, B, is equal to F. If you can spot the F pattern, then you've technically found corresponding angles. Similarly, the F could be in the opposite direction. For instance, angle G and C would be the same. Or it could be this F, an upside down F facing the other way. In this case, A and E would be the same. Let's move on to the next relationship. Alternating interior angles is when two interior angles, which lie on different parallel lines and on opposite sides of the transversal, are equal. So this is our transversal, and these are our parallel lines. Alternating angles suggest that this angle, let's call it E, and this angle D are the same. Similarly, this Z pattern could have also been this way, where angles C and F are the same. Next, we have co-interior angles. This is when angles on the same side of the transversal and inside the parallel lines are supplementary. That is, they add up to 180 degrees. For instance, notice F and D are co-interior angles on the same side of the transversal. Therefore, if D were, let's say, 110 degrees, F would have to be 70 degrees, because together D and F need to equal to 180 degrees. So wherever you can spot a C or a U, whether it's facing the correct way or the opposite way, those angles are co-interior angles. Finally, the last relationship, which is not found in the diagram, though it's an important one, are complementary angles. These are angles whose measure sum up to one right angle. A right angle is 90 degrees. In other words, if we have a 90-degree angle, such as the one you see, this angle plus this angle has to equal to 90 degrees. Here's an actual example. If this is 25, then that is 65. Therefore, we can say 25 degrees plus 65 degrees is equal to 90 degrees. So, if you had, let's say 65 and you're looking for 25, let's pretend that you don't know it's 25. You can always set up the equation. Let's call this unknown angle A. Angle A plus 65 degrees is equal to 90. Algebraically, we can move this 65 over. We end up with 90 minus 65 degrees, and that would give you angle A, which is 25. And there you have it. That is how to analyze parallel lines and the angles they make with lines crossing them.